For the next few minutes, we will look at diluting and fortifying pharmaceutical mixtures using the equation CsVs equals CdVd. We will work interchangeably, of course, with ratio and proportion as well. And to best understand these concepts, we will explore using practical examples. So the objectives: explain the parameters of the CsVs equals CdVd equation, apply CsVs equals CdVd in calculating quantities of ingredients for compounding, and perform arithmetic operations with CsVs CdVd and ratio and proportion interchangeably. This is part 2 of a 3-part series. In part 1, we focused on the use of the ratio and proportion principles to alter product concentration. In part 2, we will focus on the use of the CsVs CdVd equation and of course compare our responses using ratio and proportion. Just to recall, when we speak about the concentration of a drug, we are making reference to the amount of active pharmaceutical ingredient or API per unit volume of quantity of substance in the whole product. Now, we looked at ratio and proportion and how we can use that to either fortify or dilute our products. And now we're going to be focusing on CsVs CdVd equation. Other methods include alligation medial, alligation alternate, and that we will look at in part 3 of the series. Now, this CsVs equals CdVd equation represents, of course, a proportional relationship where the left side CsVs equals to CdVd, which is the right side of the equation. Now, each of these sides of the equation forms a ratio, and it is dimensional in that, of course, you're looking at two things here with the concentration being included, and we know the concentration in terms of those unit of measurement. You're looking at mass over volume, and the other dimension that we're looking at here in terms of your V in both the right and the left side would be the total volume for either the stock or the diluent that you are working with. So what exactly is CS? That is the concentration of the stock, and VS is the volume of the stock. Now remember, when we're looking at ratio and proportion, we looked at it in terms of what we have. So in this case, what we have would be your CS, VS, which is the concentration, and the volume that you are starting out with. All right. Now the second component would be your CD, which is the concentration of the dilution or the product, and VD, which would be the volume of the dilution or volume of the product. Now, in terms of our second statement or question, this would be what we want. So the product or the end result, this is what your CD or your volume of dilution represents. Now, let's take a look at our first example. And in this example, we're going to use the label instructions that is in the figure on the left to, of course, respond to the questions that follow. So in this case, you're going to be calculating the volume that would be occupied by the dry powder. So you have this antibiotic, you need to mix it. There are some instructions within the label that is supposed to help you to go ahead and do this. Now, the label instructions, of course, provides direction for mixing. And in this direction, you will indeed find the information that you need to perform the calculation. So in terms of the volume that is occupied by the powder, it does tell you that you're supposed to be adding 55 mils of water to reconstitute the antibiotic, and once you've added 55 mils of water, your resulting suspension would be 80 mils in total volume. And the concentration that is associated, if mixed according to the manufacturer's instruction, would be 250 milligrams in each 5 mil. So in that case, it would be easy for us to say that if it is that I'm adding 55 mils of water to get 80 mils of suspension in total, the difference between the amount of water to be added and the final volume that is going to be in the suspension bottle, that would be the space or the volume occupied by the powder or the dry powder that was not yet reconstituted. Now, let's not lose sight of the fact that we're trying to reconstitute this antibiotic, this bottle that you're seeing here on your screen. The final volume should be 80 mils, and in terms of the concentration, that is 250 milligrams per 5 mil, once we add just 55 mils of water to the bottle. Now, your prescriptions will not always be this straightforward, where you have a product, for example, in this case, that is 250 milligrams per 5 mil, and your prescription is asking for 250 milligrams per dose, in which case you would, of course, instruct the patient to take just 5 mils per dose. There are some times when you will be asked to modify the concentration of the product that you have to a specific volume that the patient can either measure, and sometimes these are done for patient-specific reasons. So in this case, you have a prescription of 125 milligrams of amoxicillin every 6 hours for 7 days. What volume of suspension will be produced if the stock of amoxicillin powder for reconstitution is diluted such that 125 milligrams of the drug be contained in each 5 mil? That is a concentration of 125 milligram per 5 mil instead of the 250 milligram per 5 mil. You will need to, of course, calculate the volume of water to be added to the powder. Let's see how we do that. Alright, so still you have your prescription there, amoxicillin 125 milligrams, that's the single dose, and we want that in 5 mils. Now, in terms of the stock that is available, or what you have, is 250 milligrams per 5 mil once reconstituted will give a total volume of 80 mils. Now, we want to reconstitute the stock such that the final concentration is 125 milligram per 5 mil. This is what we want. Now, we must dilute all of the stock to obtain this concentration of 125 milligram per 5 mil. Now, we don't know what the final volume of the diluted suspension will be, but we know that the amount of drug that is in stock will, of course, also be the amount of drug in the diluted suspension. So that is 250 milligrams per 5 mil, and once that's reconstituted, it's 80 mils. So based on that information, you can go ahead and calculate the total amount of drug that, of course, will be in the diluted suspension. And so here we're going to be using ratio and proportion to determine the amount of drug in the stock that we have available. So what information do we know? We know that we have 250 milligrams of drug in each 5 mil. So if you have 250 milligrams in each 5 mil, then how much milligrams will you have in the 80 mils? And once you work that out, you should get 4,000 milligrams in terms of your response. Now the next thing is to identify the concentration of the diluted suspension, which is what we want. That is 125 milligram per 5 mil. After that, you're going to be determining the final volume of the diluted suspension. So we have two bits of information here already. So we know that we want a concentration of 125 milligram per 5 mil. That is what we're aiming for. And in terms of the total amount of drug that we have, we know we have 4,000 milligrams. So the second side of that relationship using ratio and proportion would be then that 4,000 milligram would be contained in X mil. Once you work that out, you should get 160 mils in terms of your final volume. So now that we have established that we need to dilute the 4,000 milligram of drug that we have in the bottle up to 160 mils to get a concentration of 125 milligram per 5 mil, there is some information now that we need to, of course, work towards. So we need to determine the volume of the diluent that is supposed to be added to prepare the diluted suspension of 160 mils. That total volume of diluent that we just worked out, or the volume of the dilution, is the total amount in the entire system. So once you dilute or reconstitute the antibiotic powder to 160 mils, that will include the water for reconstitution plus whatever volume is occupied by the powder. So all of that is incorporated into the 160 mils. So in order to correctly determine how much water is needed in the bottle to ensure that you have that exact concentration of 125 milligram per 5 mil, we need to know what the volume of the powder is. And then we're going to be taking the difference in terms of that volume of water from the total volume of the dilution or the total volume of the suspension. Now we did calculate the volume occupied by the powder earlier. Now remember, this is the antibiotic that we're mixing. It's 250 milligram to 5 mil, total volume 80 mils. Now that information has not changed. All right. So all we're doing is going to be diluting the same 250 milligram per 5 mil to 125 milligram per 5 mil. So in terms of the volume that is occupied by the powder that is in this bottle here, that volume will not change. And so this is what you're supposed to be getting when you calculate the volume occupied by the powder. Remember, 55 mils of water for reconstitution, and the final volume is 80 mils. So once you take the difference of those two, the volume was 25 mil. That's the amount of space occupied by the powder. So now that we have established that the powder occupies a space of 25 mil in the bottle, we can now go ahead and determine how much we need to add for the 160 mils of reconstitution or dilution that we need to prepare. So to determine the volume of diluent, of course, you're going to take the total volume that you have, which is the 160 mil, that's what we're aiming for. Subtract the powder volume from that 160 mil, and what that will tell you is how much water for reconstitution you should add to the bottle to prepare a suspension with a concentration of 125 milligram per 5 mil. So once you do that correctly, you should be getting 135 mils in terms of the amount of water for reconstitution. Now, how long will this regimen last for per, based on the prescription that you're given? So you have 125 milligram every 6 hours, and that is to be given for 7 days. Let's work this out. So in terms of how long, recall in our previous lessons, we looked at dose, frequency, and duration, and those information will help us to calculate how much of the medication to be dispensed. So in this case, 125 milligram, we just put that amount in 5 mils because that was what we diluted it to be in terms of the concentration. So in terms of how much the person is taking per dose of the medication, that is 5 mils. How frequently? 4 times for the day, so Q6H. And then the duration in this case is 7 days. Once you take the product of all of those, you should get 140 mils. Now, this means that when the stock is reconstituted to 125 mils, we will indeed get a total volume of 160 mils of suspension. So if you should look at this in terms of will it cover the total amount that is needed for the regimen, yes, 160 mils, the patient only needs 140 mils, so that would complete the prescription. Now, when you look in terms of CsVs equation, let us see how we could go ahead and respond to this same question. So you can pause the recording at this point and you can think about it. So what will be your stock concentration? What would be the volume of your stock? What would be the dilution? And what would be the concentration of the dilution? Now let's take a look at what the parameters are for the CsVs equal CdVd equation. I hope you came up with this correctly. So in terms of what you have, or the concentration and volume of your stock, concentration is 250 milligrams per 5 mil. Because recall what we had was that antibiotic with 250 mils, 250 milligram per 5 mil, and we want to reconstitute it to 80 mils. Now, in terms of what we want, based on the prescription that you have here, it's 125 milligram in each 5 mil. How much are we going to be diluting the product to get the 125 milligram per 5 mil? We don't know yet. And so that would be the unknown in this equation, which is your VD, and that we will work towards solving for. So once you've solved for VD correctly, your outcome should be 160 mils. Now recall that VD represents the total volume for the product that you want. But in this case, you also need to consider that volume or space occupied by the powder. So what did we calculate that to be? We're adding 55 mils of water to a 80 ml bottle, and in terms of the volume of the powder, that was 25 mils. But we're not reconstituting to 250, now we're reconstituting to 160. So we subtract the volume occupied by the powder, which is a 25 mil, and that will give us the total volume of water for reconstitution that we need to add to get concentration of 125 milligram per 5 mil. So you have just used ratio and proportion and CsVs equation interchangeably. In part 3, we will look at adjusting or determining concentration and quantities using alligation method, which is alligation medial and alligation alternate.